Mathematics is a widely used concept in the world we live in today, as well as the world centuries ago. You are probably bored by the various areas of mathematics you were forced to learn in school and constantly wondered, when am I ever going to use this in real life, right? Although math seems like it's just there to confuse you, it's actually involved in almost everything that makes up the real world. My primary focus is on architecture and how ancient and modern societies utilize geometry in their constructions, which ultimately constitutes the world today. Architecture is the art or practice of designing and constructing buildings. So how does designing and constructing buildings have anything to do with geometry? Well, let me explain. Architects utilize geometry to define the spatial form of the building they are designing. They use shapes and combinations of shapes to determine how they want the area to look. For example, a square window and a rectangular door with a circle window embedded. These shapes are all considered intensely to create a design that is considered to be harmonious. Well, what about ratios? How are they used in architecture? Well, ancient Roman architect Vitruvius believed that architects should design according to fine ratios when constructing, for without symmetry and proportion, no temple can have a regular plan. Symmetry and proportion are crucial geometric components used in architecture in order to create safe and stable buildings. You wouldn't have a 200-kilo roof on top of stilts that can only support 100 kilos, would you? This verifies that proportion is necessary. Symmetry is also required in order to be able to utilize similar materials on both sides. This precise ratio is known as the golden section ratio and is known to be the building block of all life and is the hidden code evident in all aspects of architecture. Let's consider the ancient pyramids in Egypt. How were they constructed using geometry? Pyramids generally consist of a base shape with 4 triangles that all meet at the vertex. Shapes are a part of geometry. Angles were determined in order to figure out how slanted the pyramid slopes would be, which also required geometry. Before construction, the area of the base of the pyramid would need to be calculated in order to figure out what materials were needed. As you can see, the construction of the ancient Egyptian pyramids would not be possible without geometry. So we've spoken about how architecture incorporates shapes, ratios, symmetry, proportion, and angles. But what about tessellations? Buildings are often decorated with mathematical objects. Take a look at the tiles on the floor in a bathroom, for example. You'll probably notice that they are a combination of shapes situated side by side. Or what about a fancy carpet? Tessellations can be seen here also. Geometric figures, forms, and transformations build the material of architectural design. Look at the image below from a building. Can you see how the shapes have been transformed to create a pattern? These shapes have been slidden, flipped, and turned. Another aspect of geometry that architecture utilizes is composition. Geometry adds to composition by associating shapes and forms with elements, as well as proportions, angles, and transformations as relations between them. Furthermore, architectural space derives from the concept of geometric space. When you look at a building, you probably look at the shapes used and the designs within the building, but do you consider the processes involved? Robin Evan dictates that the shapes of the buildings are dormant, and that geometry has been active in the space between and the space at either end of the building. This concludes that architecture involves more than just basic geometric shapes, and also involves the processes. So how does geometry and architecture refer to the modern world? Let's look at the Sydney Opera House. The designs of the Opera House is made up of vaults that are all comprised of triangular sections of spherical shells with the same radius. Who would have thought that there was actual geometric reasoning behind this structure? Symbols and scale diagrams are frequently practiced at school, but how does this relate to the real world? When designing a house, floor plans need to be drawn up which will ultimately use scale diagrams and symbols. For example, a shower may be drawn as a square with a cross. Due to the fact that this is almost impossible to draw objects to scale, various scale diagrams will be used. For example, if we have a house and we need a truss to support the roof, and we know that this side is 5 meters, we then know that the truss also needs to be 5 meters. What about dimensions? When will we ever use dimensions in real life? Architects are required to understand and utilize dimensions in order to know how big or small parts and materials are, and if they will fit, line up, and are equally spaced apart when needed. Additionally, architects use dimensions to measure how large the trusses need to be in order to connect the structure on the floor to the truss structure at the ceiling. In a house, maths is used to figure out the size of the windows or doors, width of hallways, angle of staircase, floorboard and bathroom tile tessellations. In terms of architecture, measurements and angles dictate how we use maths in real life and how they're required within the house. So we now understand how geometry is used within architecture, but did you know that there are actually more areas of maths that are also used in building? And more importantly, how does this relate to the real world? I'm sure you've all struggled to realise when you would even need to use trigonometry in real life, right? Well, architects use trigonometry almost every day. Trigonometry is used to determine the angle of the building placement so decisions can be made on its best orientation for sunlight or wind flow. It's also used to measure land and to find the height of the building if the distance from the structure and the angle between one's eyes and the top of the building is known. Calculus can be used within architecture, which proves that most definitely relates to the real world. Calculus can be used to help calculate structural problems so that buildings can be designed to hold up the weight of the materials and support itself from internal and external energies. For example, an architect would use statistics to figure out when they should start construction. In this graph we can see in the months which month has the most rainfall. So in this case it would be best to start building in this month as that's when the least rainfall is and when there would be less days off due to rain. Probability and statistics often feature in education, but when will we ever use them? Well, architects use probability and statistics to help analyse data like geological and geographical information and structural specifications. This ensures that the building is situated in an ideal location and is safe. Statistical analysis is used for determining the best value for money in terms of material, equipment, and labour. This just goes to show that statistics are actually used within the real world. And finally, the most dreaded topic, algebra. How could this possibly be used in the real world, you ask? Architects use the formula for the area of a triangle when constructing a basic roof, in which they need to determine the slope of the roof also to figure out what materials and how much of the materials they will need. Algebraic equations are also used by architects in construction, as they need to figure out what they can spend their money on to fit within the budget. For example, $500 minus X equals $150. They may use this equation to figure out how much they can spend on the last object in order to complete their design. The points listed above prove just how geometry and mathematics can feature in real-life situations. In this circumstance, how it exists in architecture.